So today we're going to be talking about microscopy. And before we go into anything, let's just recap on what we've been through before in school. So microscopy is a topic that we've touched on in KS3, so in year 7, year 8, and year 9. But right now for GCSE level, we're going to go into it in a bit more detail. So here on the screen, we can see a light microscope. You might have used this before in school, and this should look quite similar to the ones that we've been through. So now before we go into the different parts, try to remember what the name is of each of the components of the light microscope. So firstly, on the top, we've got the eyepiece, and this is the eyepiece lens. And this is the part of the microscope that we look through. And then next, below that, is the objective lens. So these are responsible for magnifying the image, and there are different types of magnifying lens, or objective lens, with 3 different strengths of magnification. So normally in class, you might have used it where you twist it round. And then below that, we've got the stage. So the stage is where we clip our microscope slide, whatever specimen it is that we're trying to study, and we're holding it in place. Below the stage, it's not labeled on here, but I'll draw on the side. We've got here, that's where the light goes through. So here is the mirror that reflects the light. So this is the light, or sometimes you might call it the mirror. So what this does is it shines the light through the specimen so that we can see it more clearly. And that's why it's important to make sure our specimen is thin enough so that light can go through, and then we can study the different parts of our specimen. Next, on the left-hand side, we've got 2 different twist circles. So firstly, it's the fine adjustment knob. And then above that, we've got the coarse adjustment knob. So we can tell the difference because of their sizes. So the coarse adjustment knob is a bit bigger and it's rougher on the outside. We can see that in our diagram here. So these are both responsible for helping us to focus the image so it's more clear. So if, for example, you're looking in and it's quite blurry, you can't see what it is, where the specimen is, then we'll twist the coarse knob first and then the fine knob to ensure that the quality is clear. Okay, next let's talk about how we can determine the overall magnification. So like we mentioned before, we've got the eyepiece lens, which is where we put our eye on, and we've got the objective lens, which is the one that you twist around. So they each have their own magnification. The eyepiece lens of light microscopes has a magnification of 4 times. And the objective lens, there's usually 3 different settings. So it should be maybe 4 times, 10 times, or 40 times. So let's say we've set it to the one that is 10 times. How can we calculate the overall magnification? If we look through our eyepiece lens, it makes the object 4 times bigger. And then if we look through the objective lens, it makes our objects 10 times bigger. So we would multiply the 2. So the overall magnification in this case is 4 times 10, which equals 40. So here is the equation that joins together image size, actual size, and magnification. So we can see that the image size is on the top. Sometimes you might see it written as image size equals actual size times by magnification. How you arrange the formula is completely up to you. Sometimes I feel like the triangle is what works best for me. And yeah, we can see that from this equation, one way we can guess how things are sorted is we know that the image size is always larger than the actual size. So the actual size, we're talking about how big the specimen is, and the image size is how big we can see it in our diagrams. Say, for example, in the test, they might have a drawing or a photo of the specimen, and it's a lot bigger than it would be in real life. So that's how we know that this is talking about the image size. So now let's apply this to a question. So the question says the image size is 5 millimeters and the magnification is 10 times. What would the actual size be? So what they're saying is image size equals actual times by magnification. So when in doubt, write out the equation. and the image here is 5 mm, actual size is unknown, and their magnification is 10 times. So then to find the actual size, we would do 5 divided by 10, which gives us 0.5. And don't forget to put in the units as well. So we're using the same units that they've given in the question. So it's 0.5 mm. Next, let's talk about the difference between the light microscope and the electron microscope. So the light microscope is the one that you normally use in school, and that's the one on the diagrams that we spoke about. The electron microscope is not as accessible, so you won't be able to use it in school. So firstly, let's compare the price. The light microscope is cheaper to use, whereas the electron microscope is more expensive. Then, thinking about the maximum magnification, the light microscope has a maximum magnification of 2000, whereas the electron microscope has a higher magnification, and it could have a maximum magnification of up to 2 million. Resolving power-wise, the light microscope has a weaker resolving power, whereas the electron microscope has a higher resolving power. And then their use. So the light microscope is easier to use, so that's why you're able to use them in a classroom setting. And the electron microscope, on the other hand, is more expensive and it's larger. That's why they're used in more specialist cases. So far this brings us to the end of talking about light microscopes and electron microscopes.